We are still continuing with our lessons, and just like I've been always telling you that you are new to the channel or you have been visiting the channel regularly but you have not subscribed to the channel, just subscribe to it and click on the notification bell so that you can get access to all the other contents that will be uploaded here. We are continuing with our lessons in elective mathematics and under the binary operations. So now when we look at the binary operations, not always that you will get it in a linear form. Sometimes it could be given to you in a tabular form like this. Let's read what we have on the board. It's a binary operation. The asterisk, this operation, asterisk, is defined on a set T. Set T. Look at it. Set T. And that is P, the element in set T. We have P, Q, R, S by the following table. So the operation star or asterisk is operating on the set P in the table like this. So we say P operation P, we get Q. Q operation P, we get S. R operation P, we get P. S operation P, we get R. The same, we take those at the top, then we operate it upon all those at the vertical side. So the horizontal aspect at the top is operating on the vertical aspect in the table. Q operation P, we get S. Q operation Q, we get R. Q operation R, we get Q. Then Q operation S, we get P. R operation P, we get P. R operation Q, we get Q. R operation R, we get R. R operation S, we get S. The same applies. So in that order, it follows. Let's look at the question. The question is saying, show whether or not the set T is closed under the operation. Show whether or not the set the set T is closed under this operation. When we talk about a closed set, it means the members in the set, just like a family, they are closed. People outside the family are not part, or elements outside the set is not part. Meaning, whenever we take any element within the table, they are supposed to be in the set given here. If we have any element within the operation or the table outside the element here, it means it is not a closed set. Just like I will see in a classroom, and someone outside the classroom, if we are taking prefectship or prefectorial appointment and we appoint someone outside the classroom to be a prefect in the class, it means it is not closed. But if all the people or the prefects that are being elected are from the class, then we say it is a closed. Let's say in school, SHS or college or university, and all the SRC members are from one particular class or one particular hall, it means it is a close, because whatever they are doing, they will do it at the benefit of those hall or that class alone, neglecting the other aspect, because it is a close prefectship or close executive. But if it is external, one from different hall, they are from different halls coming together to form the association. If they are planning, their plans will be extended to all the various halls or various classes, rather than being in a particular class alone or hall alone. So that is what we are after, a closed set. So we are saying, show whether the operation is closed under the set T. And look at it very carefully. When we take P to operate it on P, we get Q. Q is in the set. When we take Q to operate on P, we get S. S is in the set. Any element that you can, I repeat, any element within the table that you can find within the set, any element that is in the set and they are all found in the table makes it to be a closed set, making this table or elements that you can find within this table, they are all in the same family, set T. And so therefore we say the operation is closed under the set T. Because look, if supposing to be that we operated P, let's say P it was operated on R and the result was, let's say, F here, and you look at it and there is no F in the table, the set T, it means the operation is not closed under the set. But since all the elements in the table are found in the set T, then we say that the operation is closed under the set T. That is it. Okay, so in this case, question 1, T, show whether or not T is closed under the operation. We say the answer is T. The operation is T is closed under the operation since all the elements found within the table are in the set T. In this case, we can rewrite it and say, my board is full, I don't know where to write again, and I also need some space as well. We can say P operation P is Q, and Q is in the table, the set. The same applies R operation S. The result is R operation S. The result is what? S, and S is in the set. So therefore, we say T is closed under the operation since all the elements in the table are found within the set. So we are done with our I. Let's come to the identity element, which is II. The question 2. Let's find the identity element within the table. Like I was telling you from our previous lessons, that identity element is any number or any element when operated on another number, we get that same number. The number that the identity element was operated on is the result. That makes that identity. So we look at the table, you look at all the elements within this table, which number or which element is when operated on a different element, we get that different element as a result, making that number seem like a zero number, making it seem like a zero number or element. Let's say when we took P to operate on P, we get Q. That means we didn't get P as a result. So P here is not, this P is not an identity element. Q operated on P, we got S, we didn't get the P, so Q is not an identity element. R operated on P, we got P. Have you seen? This R was operated on P, we got P, this P. Okay, let's put it aside. S operated on P, we got R, we didn't get S. So let's put it aside. Now let's come to this one. Let's come to the second line, Q. P operated on Q, we got S. Q operated on Q, we got R. Have you seen? Under the Q, we got R, which is not Q. R operated on Q, we got Q. S operated on Q, we got P. Okay, R operated on R, we got, P operated on R, we got P, which is R is not. Okay, Q operated on R, we get Q. We didn't get the R. So have you seen? R operated on R. I am after a number which one operated on this. The one here, we will get that same number here, not the number here. When we take any number or any element at the top here and operate it on the vertical line, we must get the result of the vertical line. That makes it an identity element. So K operated on R, we got K, we didn't get the R, so let's forget. R operated on R, we got the R. So have you seen? R operated on S, we got S. So the identity element in the table, you can see it yourself, is what? R. And so therefore we say our identity element, so R is the identity element in the table. In the table, you can go on to say since any number operating on R, the result is the same number. Since, but you can say, let's say, since R operation Q equal to Q. R operation Q equal to Q. R operation P equal to P. Then R operation S equal to what? S. R operation R equal to R. Even if we are to turn it S operation R, you will get what? S. Let's see. S operation R. We got S. Have you seen? R operation R. We got R. Q operation R. We got Q. P operation R. We got P. So anytime we take any number to operate it on R, we get that same number or that same member or element. So therefore, R is the identity element in the table. Anytime you are solving the question and you get it in a tabular form, that is how we find the identity element. Thank you. Let's continue. I intentionally brought this question so that we can solve a lot or we can do a lot under this. Then let's see. Let's check if the operation is commutative. If the operation is commutative. If the operation is commutative. When we talk about commutative number, I said when we reverse the number from the left side and the right side, the result should be the same. For example, 2 plus 3, our result is what? 5. If we are to reverse from the right side to the left side, 3 plus 2, the result is still 5, making what? So we will know that this is what? Commutative. In multiplication to, let's say, 6 multiplied by 2, the result is what? 12. The same, when we reverse it, 2 multiplied by 6, we get what? 12. So this is what we are referring to as commutative. Let's look at the table here and see if the operation, this operation is commutative. So in this case, we will say, let's pick any element from the table. Let's see. P operation P. No, let me neglect the P because P operation Q is S. P operation Q. We got what? S. Okay. Then let's reverse it to see Q operation P and see if we will get the same S. We said P operation Q, we got S. Then Q operation P, we still got what? S. Let's take another one to see. Let's see. R operation S. R operation S. R operated on S. We got S. Then let's reverse it. S operation R. And what's the result? S operation R. The result is S. So it's commutative and it is very clear. Okay, now you can check from the table to see more. I will give you an assignment with respect to this. You to find P operation R as well as R operation P. P operation R and R operation P. Write it. Let's see the results you get for this to see if you've probably or really understood it. Thank you.